In 2022, the James Webb Space Telescope sent back an image of galaxies 13.5 billion light years away. And that light had been traveling since before Earth existed, before our sun ignited, before most stars in the universe were even born. When people saw that image, they said what humans always say when confronted with the cosmos, that it makes them feel so small, and they were completely wrong. That feeling of smallness you get when you look at the night sky represents a failure of imagination, a cosmic misunderstanding that has plagued our species for millennia. You're not looking at something foreign out there because you're looking at your own birth certificate, your autobiography written in starlight. And when you truly understand what I'm about to tell you, you'll never see yourself or anything else the same way again. Most people carry a medieval map in their heads, even though they've updated the graphics. They know the Earth orbits the sun, and they can tell you the sun is one star among hundreds of billions in our galaxy, and they'll nod along when you mention the Big Bang. But emotionally and psychologically, deep in their bones, they still feel like Earth is the center of something, like humanity is the main event and the universe is the stage we perform on. That feeling is comfortable and warm, and it's also a cosmic lie we've been telling ourselves for 10,000 years. Copernicus understood this when he published his book in 1543, the one that moved Earth from the center of the universe to just another planet orbiting the sun. And the church wasn't thrilled about it. Galileo pointed his telescope at Jupiter and saw moons orbiting another world, which was proof that not everything revolved around us. And they put him under house arrest for the rest of his life. Giordano Bruno suggested the stars were other suns with their own planets and maybe their own life. And they burned him alive for saying it. The history of cosmic understanding is written in the resistance to it, because every time science revealed our true position, we fought back, not wanting to know. But here's the thing about what Copernicus started, what Galileo was imprisoned for, what Bruno died for, it didn't diminish us at all. It liberated us. Because once you stop pretending you're at the center, you can finally ask the real question about what we actually are, if we're not special by location. Let me take you back now, not to the beginning of human history, but to the beginning of everything. The universe emerged 13.8 billion years ago from a state of unimaginable density and temperature, with every galaxy, every star, every planet, and every atom in your body compressed into a space smaller than a proton. That's not poetry, but observational cosmology. And we've measured the afterglow of that moment with extraordinary precision. The Planck satellite mapped temperature variations of 100,000th of a degree across the entire sky, capturing the cosmic microwave background radiation that's washing over you right now. Ancient light stretched into microwaves, a faint whisper from the birth of time itself. Those first few minutes after the Big Bang produced the universe's first elements, which were hydrogen, helium, and a trace of lithium. And that was the entire periodic table for millions of years. The universe existed as a hot, expanding cloud of the simplest atoms possible, with no carbon, no oxygen, no iron, and nothing you need to build a planet, let alone a person. If the story ended there, and that was all physics allowed, you wouldn't exist and I wouldn't exist, and there would be no chemistry complex enough to create life. No molecules, no proteins, no DNA, just an eternal sea of hydrogen and helium cooling and dispersing into darkness forever. Gravity had other plans for all of that primordial gas. Over hundreds of millions of years, gravity pulled that gas into clumps that grew denser and hotter until something extraordinary happened in their cores. Nuclear fusion ignited and the first stars were born. And these weren't stars like our sun that are stable and modest and middle-aged. These were monsters, hundreds of times more massive, burning through their nuclear fuel at a furious rate, living fast and dying young. Inside those stellar furnaces, hydrogen atoms were being squeezed together to form helium, while helium was being crushed into carbon, and carbon into oxygen, and oxygen into silicon. The periodic table was being written in fire, because stars aren't just balls of burning gas. They're cosmic factories manufacturing the elements of existence itself. And every atom heavier than hydrogen and helium, every atom that makes chemistry interesting and makes biology possible, was forged in the heart of a star. The problem was that these elements were trapped and locked inside the star, and what happened next is how they got out to become planets and oceans and bones and brains. The star exploded. A massive star that exhausts its nuclear fuel collapses under its own gravity, and the core implodes at a quarter the speed of light before rebounding in a cataclysmic explosion we call a supernova. For a few weeks, a single dying star outshines its entire galaxy of hundreds of billions of other stars. And in that explosion, the star's guts scatter across light years of space. Elements forged over millions of years get hurled into the void, and in that catastrophic moment with temperatures and pressures that dwarf even the stellar core, elements heavier than iron are created, including gold, platinum, and uranium. The explosion itself becomes a forge. We now know that some of the heaviest elements come from something even more violent, which is neutron star mergers. In 2017, LIGO detected gravitational waves from two neutron stars spiraling into each other 130 million light years away, and these were ripples in space-time itself that Einstein had predicted a century earlier and that we finally heard. When telescopes turned to look at that collision, they found the spectral signatures of gold and platinum being created in real time, and we watched the universe make jewelry. Let me make this concrete for you now. The calcium in your bones was manufactured in a star that exploded before our sun was born, and that same calcium is in the bones of every mammal on Earth, every bird, and every fish with a skeleton. You share your bones with a blue whale because you share a supernova. The iron in your blood, the very atoms carrying oxygen through your body right now, was forged in the collapsing core of a massive star. The oxygen you're breathing, the carbon forming the backbone of every molecule in your body, and the nitrogen in your DNA all came from stars that no longer exist, with every single atom cooked inside a stellar furnace. Think about what that means for a moment. The atoms in your left hand probably came from a different star than the atoms in your right hand, and you are literally assembled from the scattered remains of multiple stellar explosions that were gathered together by gravity over billions of years and arranged by chemistry and biology into something that can contemplate its own origins. You are not looking at the universe, because you are the universe examining itself, and you are stardust that has organized itself into a structure complex enough to study stardust. That's not a metaphor, and it's not inspirational calendar nonsense. That's peer-reviewed astrophysics published in Nature and Science, and the data is in 1990, at Carl Sagan's request, NASA commanded Voyager 1 to turn its camera around from 3.7 billion miles away and take one last photograph of Earth, and there we were as a pale blue dot, a fraction of a pixel suspended in a sunbeam. Every war ever fought, every love letter ever written, and every human being who ever lived existed on that tiny speck that Sagan called a mote of dust. He was right about that, but he also understood something most people miss when they feel small, which is that the mote of dust is thinking about where it came from. The laws of physics that govern your kitchen also govern a galaxy 10 billion light years away. And we've tested this by looking at light from distant quasars, which are blazing cores of ancient galaxies, and analyzing their spectrum. We find the same atomic transitions, the same physical constants, and the same chemistry everywhere we look. The universe isn't just comprehensible, but uniformly comprehensible. With one set of rules playing out across 93 billion light years of observable space and 13.8 billion years of time, when Edwin Hubble discovered that the Andromeda Nebula was actually another galaxy entirely, a separate island of hundreds of billions of stars. He multiplied the known universe overnight, and we went from one galaxy to billions. In every one of those galaxies, the same physics applies and the same elements exist and the same forces operate. Think about what that means for your place in the cosmos. Given that you evolved on a planet orbiting an ordinary star in the unfashionable suburbs of an ordinary spiral galaxy. Nothing about our location is special, and we have no privileged vantage point. Yet from this unremarkable corner of space, you can deduce the laws governing the entire observable universe. You can calculate the age of the cosmos and determine the chemical composition of stars you will never visit, and you can detect gravitational waves from black holes colliding a billion years ago. Einstein predicted those waves in 1915, and LIGO detected them in 2015 as ripples in space-time from a collision 1.3 billion light years away. And we heard the universe vibrate. That's not insignificance, but power. Specifically the power of pattern recognition and mathematics and the scientific method. And it emerged here in you as a product of this very universe. The cosmos grew a brain, lots of brains actually, and those brains can comprehend their own origins. But here's where humility enters the picture, because all this cosmic understanding I've been describing applies to roughly 5% of the universe, and nothing more. Ordinary matter, including protons, neutrons, and electrons, which is the stuff that makes stars and planets and people, accounts for less than 5% of the total mass energy of the cosmos. About 27% is something we call dark matter, and we know it exists because the math doesn't work without it. Galaxies spin too fast and should fly apart based on the gravity of the matter we can see, but they don't because something invisible is holding them together. We've spent decades and billions of dollars trying to catch it directly with physicists at CERN, running experiments and detectors buried miles underground. Every year the constraints get tighter, and so far we've found nothing with every detector coming up empty. Dark matter is the universe's most successful fugitive, or perhaps we're looking for something that doesn't exist in the form we expect. The remaining 68% is dark energy, which is a mysterious force causing the expansion of the universe to accelerate. Every galaxy is rushing away from every other galaxy faster and faster, and we don't fully understand why, even though we can measure it and quantify it. Here's something most people don't know about this situation. We have two different methods of measuring how fast the universe is expanding, and they don't agree with each other. Scientists call this the Hubble tension. And it's not a rounding error because something is wrong with our understanding or something is strange about the universe. Your place in the cosmos might be even more unusual than we thought. You're made of star stuff, but you're made of the rare stuff, the exotic stuff, the 5% that clumps together and forms chemistry and builds complexity and occasionally wakes up. Most of the universe is a mystery even to itself, assuming it could contemplate itself, which as far as we know, only you can do. Here's what's strange about consciousness. The atoms in your brain aren't special, and they're not magic. They're carbon, oxygen, hydrogen, and nitrogen, which are the same elements in a rock, in seawater, and in the atmosphere of Jupiter. But arrange them in exactly the right pattern, and they start asking where they came from. The universe doesn't just contain minds, because it produces them reliably and perhaps inevitably, and that should terrify you as much as it amazes you. It means you're not an accident, but an expression, a phase transition of matter into something that wonders. Astronauts report something called the overview effect, which happens when they see Earth from space as a blue marble floating in blackness, and something shifts in their psychology. Depression decreases, and petty tribalism falls away, and they come back changed by the experience. The cosmic perspective isn't just philosophy because it's measurable neuroscience. And seeing your true context physically alters how your brain processes meaning. You don't have to go to space to feel it because you just have to understand what I've been telling you. For most of human history, we asked about our place in the cosmos, as if we hoped to find out we were special and central and chosen. And every time science answered, it said, no, you're not special in that way. Earth is not the center of the solar system, and the sun is not the center of the galaxy. And our galaxy is not the center of the universe, because there is no center at all. But here's what we kept missing through all of that. We are special by capability rather than by location. Of all the matter in the universe, including all the dark matter and dark energy and all the stars and gas and planets, the only stuff, as far as we know, that can ask about its place in the cosmos is sitting on this pale blue dot. The only matter that writes symphonies and builds telescopes and agonizes over its own mortality and cries at the beauty of a sunset is us. The James Webb Space Telescope is now finding organic molecules, which are the chemistry of life, in the atmospheres of planets orbiting other stars. And the building blocks are scattered everywhere we look. Maybe life is common and maybe intelligence is rare, or maybe we're alone in the observable universe, like a single candle in an infinite dark room. Some scientists argue exactly that position through the rare Earth hypothesis, which suggests the conditions for complex life are so improbable that we might be unique. If that's true, you're not just significant because you're irreplaceable as the only witness. Either way, you matter. Because if life is everywhere, then you're part of a cosmic community beginning to find itself. And if life is rare, then you're carrying the entire burden of cosmic self-awareness on one small world. We are the universe's way of knowing itself. And that's not ego, but responsibility. Every time you look up at the night sky, you're continuing a tradition that stretches back to the first human who wondered what those points of light were. You're participating in the same cosmic inquiry that built Stonehenge and the pyramids and the Hubble Space Telescope and the James Webb, and you're asking questions. The universe has been waiting 13.8 billion years to hear. There is so much left to discover because we don't know the true nature of dark matter, and we don't know why the universe is accelerating apart, and we don't know if our universe is one of many. Every answer opens 10 new questions, and the horizon of ignorance recedes but never disappears. Here's what keeps me up at night. The window might be closing because stars are dying faster than they're forming now. The universe is slowly running out of fuel, and in the far future, trillions of years from now, the last stars will burn out and the cosmos will go dark and cold. Consciousness, the universe's only way of knowing itself, might be a brief flash in cosmic history, a momentary awakening between eternal sleeps. The question isn't whether you're significant because you are significant. You're made of ancient stellar corpses, and you're the universe grown complex enough to ask questions. And you carry 13.8 billion years of cosmic evolution in every cell of your body. The question is what you will do with the brief moment when the universe is awake. That's what our place in the cosmos really is. Not a location and not a rank on some imaginary hierarchy, but a relationship and a responsibility. You are not in the universe because you are the universe, temporarily arranged into a pattern that can feel wonder and loss and curiosity and love. The cosmos is within you, literally and chemically and measurably. And that changes everything.